Welcome. In this demonstration, we'll be finding out the future value of annuity. And as we can see in the table in front of us, we are looking at a 6-period annuity as seen on in the column on left. There are 6 cash flows, each $100. The rate of discount is 10%. And what is the future value at the end of 6th period for this annuity? To do that, let's just lay it out once again. 0 equals this plus 1, control D, control D, control D, and 6 periods. The cash flow is 100, equals up arrow, and then that's cash flow. Now we have to find out the future value of each of these, which means transporting this first cash flow to 6th period, and end of first period to end of 6 periods, which means we'll have to do this times parenthesis 1 plus $BL $2, the rate to the power of 6, so which is BK $10 minus this. So BK $10 will remain BK $10 as we paste this formula down. BL5 will change to BL6 and so on. And then B $2 will remain B $. So the interest rate will remain fixed. The cash flow could change, but it's the same. And then the compounding periods will compress as we go down. So 5 compounding periods for this cash flow, 4 compounding periods for the next cash flow, 3 for the one after that, and so on. Let's close parenthesis. This is the future value of the first cash flow, future value of the second, third, fourth, fifth, and 6th. There is no future value of the 6th cash flow because we received that cash flow at the end of 6th period itself anyway. So what is the future value of all? So the future value of annuity is the sum of all of these. Okay, now that's just one way of finding this. There are multiple ways of finding this. Now, if you recall, we can find out the present value of the annuity. So the other way of calculating the future value of annuity is use the PV function to calculate the present value. So PV rate. So yes, let's just do PV first, and then we'll complicate the matter. So PV rate, number of periods. There is no payment in between. Actually, there is a payment of $100, so minus 100. Sorry about that. There's no future value at the end. And then type is 0. So this is the present value, which we have already seen right here. Now, basically, the present value is equivalent value at the beginning. And all we need to do is find out the equivalent value at the end. So times, parenthesis, 1 plus BL2 to the power of BK10. Power of 6. That'll give us 771.56, same answer. Or we could do it another way. So let's just copy the formula. There are many ways to do this. Let's just copy the formula. So this is the present value formula. Now why don't we take a future value of the present value? So future value of rate, so that is BL2, comma, BK10. BK10 is a number of periods, comma. There's no payment now. We just have an equivalent present value, and that is what we just found out using the PV function. So that's the present value, comma, type is 0. So that'll also give us 771.56. Now we can actually use the FV function also, which we have not used so far. So let's use the FV function itself. So equals FV. The rate is BL2. The number of periods is BK10. The payment is minus whatever, BL10. And the present value is nothing. We didn't start with anything. And so there's no initial cash flow. And the type is 0. So this will also give us 771.56. So there are multiple ways to find out the future value of annuities. It's really fun. Excel makes it really fun, whole lot of fun. And so that's how we calculate future value of annuity. Thank you for listening.